Hey everyone, welcome back to the Workplace and Apprenticeship 10 videos. In this video, we're going to look at lesson 2 from chapter 6, which is talking about determining if two polygons are similar. So this here is really just an extension of lesson 6.1, just we're going to take a little bit of a different take on it. So a map is an example of a drawing that is a reduced image of the original. Most maps indicate a scale, which is the factor used to reduce the size of the original. Therefore, a correct map is an example of a perfect scale drawing. So even just look at this example, there's something that we can pull out from here, which is something called a scale factor. So your scale factor essentially tells you the proportion that your image is either reduced or enlarged by compared to your original object. And we can write it in the form scale factor is equal to new over old, or you could also write it as the diagram dimension divided by the original. So in this case here, we would have the dimension of our map divided by the dimension of the actual world. So the distance in real life. So this means that when you're asked to determine the scale factor used to create a second figure, you need to compare a measurement from the new figure to the corresponding measurement in the old figure. So one thing here that's really important is the word corresponding here. You can't just take two random sides and hope for the best. They have to be corresponding, which means that they're in the same position. So say we had two rectangles. I'll label this one length and width. And then suppose I had an enlarged version with dimensions length and width. So you'd have to use the ones that are in the corresponding side. So you'd have to use the top length and top length. The reason why I say top length and top length is because say if you're working with a different object, you want to make sure, like say we had a trapezoid, you want to use that same corresponding position. So you will want to be working with the top dimension and top dimension there as well. So they're corresponding measurements, meaning they're in the same position. So one thing that's really important to know about scale factor is that if your scale factor is greater than 1, then that means that your diagram is an enlargement of the old or original image. So if the scale factor is between 0 and 1, so it's a small decimal like 0.25 or a fraction like 1 over 4, then it's a reduction. So that means that the diagram is smaller than the original image. And an example of something to be reduced would be, say, that map that we just talked about. And just before we move on to an example, we're just going to do a quick recap about last lesson. So in order for two figures to be similar, they must, 1, have corresponding angles being the same size, and 2, corresponding sides must be in the same proportion. These both must be true in order for the two figures or two objects to be similar. So now we're going to look at example number 2 from your notes, where we're going to apply all of this information. So here we're going to determine if the two parallelograms, ABCD and WXYZ, are similar. So as I literally just said, in order for two objects or two figures to be similar, number 1, I'll write this in black. So number 1, so corresponding angles must be equal. And number 2, the sides must be proportionate. So let's start by checking the corresponding angles and seeing if they're equal. So here in our two figures, we're only given that angle B is 70 degrees and angle X is 70 degrees. That there only tells us that one angle might be corresponding, that they're equal, but we don't know about the other angles. So what we need to do is find the missing angles and see if those corresponding angles are equal. And in order to do this, we have to use those properties of parallelograms and something we learned from chapter 5 in order to find the missing angles. So some properties of parallelograms is that the opposite sides are equal in length and they're parallel. So side AD would be equal to side BC, and side AB would be equal to side DC. Same with our second parallelogram. Side WZ would be equal to side XY, and side WX would be equal to side ZY. So that there was really important for establishing the fact that we have parallel lines here. And so that should hopefully ring some bells from the end of chapter 5, where we talked about two parallel lines being cut by a transversal. So let's start off by looking at angle B here, and we can use this to find either angle A or angle C. So here we're going to choose two lines that'll be parallel, and we're going to choose a transversal. So in this case here, I'm going to choose line AB, and I'll choose line DC here to be the parallel lines, and line BC here will be our transversal. So now looking at angle B and looking at angle C here, those are on the same side of the transversal and inside those two main lines, meaning that they're same side interior angles. And if you go back and think back to chapter 5, same side interior angles are supplementary. So to find angle C, we're going to take 180 degrees and subtract 70 degrees. So subtract your known angle. So 180 degrees minus 70 degrees would give you 110 degrees. And we can do the same thing to find the rest of our angles. So now let's find angle D here, which I'll do in a different color. So angle D here. Here we're going to have to look at two different parallel lines. So this time we can use line DC. That could be cutting line CB or BC and line AD. So here we have two main lines that are parallel, AD and BC, and the transversal in this case will be line DC. So here angle D compared to angle C, those are on the same side of your transversal and inside the main lines, which means that once again these are same side interior angles. So we take 180 degrees, subtract angle C, which is 110. We would find that angle D is 70 degrees. And then we could do the same for angle A. So that would be 180 degrees minus 70, which we know from angle C here would be 110 degrees. So to find the rest of the angles, say for parallelogram WXYZ, you use the same properties. Here your angle here is 70 degrees, so it would be supplementary to angle Y, which would give you 110 degrees, meaning angle Z would be 70 degrees, and angle W would be 110 degrees. So far, our corresponding angles are in fact equal. That checks out. But just because one thing checks out doesn't mean they are necessarily similar. So you have to confirm that both the corresponding angles are equal and that the sides are proportionate. So now let's check that the sides are proportionate. I'm just going to erase all this little clutter here just so we can see just the important information. So to check if the sides are proportionate, you have to remember that you're using corresponding sides. So we can start with using the bottom of the parallelogram in each case. So what we're going to do is we're going to show that they're proportionate by showing that those scale factors give you the same fraction, or you can show that they give you the same decimal. So I'll label triangle ABC here as our parallelogram number 1, which will be our old, and then we can say that this one here, number 2, will be our new one. So we want our new over the old. So we'll go 8 divided by 12. And you could either leave that in a reduced fraction form. So you could divide both the top and the bottom by 4 to give you 2 over 3. You can also put that into decimal form, which would give you 0.67. Then I can look at side, the left side here, so WX, and side AB, so the left side of both those parallelograms. So those ones there would be 6 over 8. You can reduce this here by a factor of 2. And you would get 3 over 4, or a decimal of 0.75. So here you can tell that both of these decimals and those reduced fractions are not the same, which means that the sides are not proportionate. So in order to be proportionate, you'd have to get the exact same fraction or exact same decimal. So are parallelograms A, B, C, D, and W, X, Y, Z similar? And the answer to that is no. So you could say these two parallelograms are not similar since their sides are not proportionate. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.